Okay, welcome everybody to this webinar hosted by Evolt on DALI 2. Just a quick introduction of myself. My name's Dale Martin. I'm the Director of MLCI here in Canberra. I'm also the Zen Control Distributor for Canberra and surrounds. Worked in lighting control for a number of years, being in theatre and commercial buildings, and was the control section supervisor for a local electrical contracting company before starting my own lighting control focused company about 2 years ago. So today we're going to cover DALI 2 and speak about why the industry is moving away from other protocols to DALI 2. Speak a little bit about the transition from DALI 1 to DALI 2 and what that involves and what the differences and similarities are between them. Why it's more efficient during design and construction to use DALI 2 in your building. And within that, we'll talk about one of the key things that I think, at least, the standardization of sensors and switches within the DALI 2 standard. Also talk about standards compliance and emergency testing and monitoring, and some higher level control stuff, focused around things like human-centric lighting, DT-8, color control, and what that means. So a few housekeeping things. The presentation will go for around about 45 minutes. We'll be taking questions at the end, so feel free to send through your questions throughout the entire presentation. We'll collect them and put them to the panelists at the end. Don't worry, we won't be putting on camera or anything like that, so yeah, just type them in the question field there and we'll get to them at the end. And at the end, all participants will receive a CPD certificate. So firstly, I'd like to introduce Allan Organ. So with 10 years experience in the development of lighting control, Allan has led engineering and development teams at both Creative Lighting and Zen Control. Author of Edition 2 of the Emergency Test and Monitoring Standard, Color Sensor and General Purpose Sensor Standards, Allan represents Australia on IEC's TC34WG11, the group responsible for the development of the IEC 62386 or the DALI standards. Representing Zen Control, Allan is also a member of the DALI Alliance's Test and Certification Working Group, responsible for the development of the DALI certification platform. Domestically, Allan is a member of committees EL 041011, responsible for the adoption of IEC lighting standards to Australia, New Zealand, and LG 007, and the development of the Australia, New Zealand 2293 suite of emergency lighting standards. At work, Allan enjoys working with customers to develop new solutions to lighting control challenges, and in his spare time, you can find him climbing, cycling, and trying to learn Norwegian. So over to you, Allan.
Thank you very much. Quite the introduction there, Dale. Much appreciated. All right, hope everybody can see the screen there. We'll move right across to our agenda for today. All right. So yeah, as Dale has just introduced, we are going to have a little bit of an introduction into DALI. So this particular webinar has been intended as the first of a series of webinars that we are going to sort of step through the developments both in the lighting control and general lighting space. So what we're really trying to achieve in this particular session is to make sure that everybody is up to speed on the basics of DALI, what the transition from DALI 1 and DALI 2 has meant for our buildings, a little bit of an explanation about how we would use the DALI, and a little bit of a background on some of the key technologies, such as the emergency test and monitoring and DALI device type 8. All right, after we've finished all that, as we said, we're going to take some answers about what we are doing in the DALI space, looking for any of those questions specifically related to use of DALI and DALI 2 in buildings. And then we'll give you a little bit of a background on some of the topics that we are looking to cover moving into the future as well. All right, looks like the vast majority of you have joined up now, so we'll jump straight into the content. All right, so first of all, we're going to start right at the beginning and say, what is DALI? Now, DALI itself is the trademark given to a suite of standards, the IEC 62386 suite of standards, and they are primarily focused on the control of lighting in buildings. So traditionally, what did we have? Well, we had a lot of switch control. We had a lot of phase cut control. And in certain applications, these have worked. Certain applications, these continue to work well. But we can do a lot more. So just certainly in your traditional approaches, we had separate circuits. So if you had lights at the front of your room, if you had lights at your back of your room, if you had areas that you wanted to control separately with sensors, then you were finding that you were actually having to cable out each of those, that you were having to put a switch sensor, other sort of physical control device on those lines. We also had the options of on or off. Certainly dimmed lighting really was just a case of turning half the lights off. So fairly soon people moved into actually using dimmers for traditionally incandescent lighting. In a very similar matter though, we still had to have separate circuits. So if you wanted some lights to be at 100%, some lights to be 50%, even within that same room, you were finding that you had to cable those all the way back to the switchboard. So that's a lot of cabling for fairly redundant controls. Okay. The other issue is, of course, that phase dimming worked fairly well for incandescent lights, averagely for CFLs, and very poorly for any LEDs. To this day, it is still very difficult to get a good quality, consistent, flicker-free dimming with your traditional phase cut style dimmers. So that's why we were looking at these digital technologies. So with a DALI line, you have a single line, which can be connected either in a daisy chain, a star topology, basically any sort of format that suits your building, and you can address those independently. So within that same loop or line, you could actually have the light levels of every single device at a different level. When you set up your control schemes for your building, you can configure certain switches, certain sensors to address, to talk to just some of those lights. And because that hardware is consistent, it means that through the life of that building, you can continue to go back, you can address it, you can change it. If you find that you want to use your building in a different way, you can reconfigure these lighting levels. You can change which devices are controlled by which sensors, which button panels, which AV control system as it's moving in. So it really gives us a lot of flexibility in the design and installation of those buildings. So we talk about digital lighting control. What does that mean? Well, it means that the actual dimming signal isn't some sort of reference level that moves up and down. We're actually sending digital packets to each of these lights. So that means that each light will receive some sort of command, and it's going to contain an instruction. Now, the advantage of doing this over an analog system is that you don't get the noise. So even if a receiver on the other end has got quite a messy signal, so long as that signal is within the limits of what the standard sets out to actually have as a valid packet, then you are going to find it will receive it and it will execute that dim perfectly. Okay, so you don't have that issues of something like power line flickering, and as the light's transitioning from high to a low level, there's some sort of momentary interruption. The type of thing that happens in a real world environment. You don't have that issue because in a DALI system, you actually send a command. We say, address 1, move from your current light level to 50% over 20 seconds. And once that command's been sent, so long as it's received, it will actually start running and it will execute it. And that's worked out by every separate light in your building as well. So that means if you've got lights of different manufacturers, you've got lights of different sort of technologies, then you can have each of those ballasts, each of those devices actually determine for themselves what the best way is to get from point A to point B. With a lot of the traditional analog style of control systems, then you had the issue that, well, some devices at a particular dim level may be considerably brighter than others. Some of them may not have followed the same ramp. So as you were transitioning between levels, it was very hard to get that consistent. when you've got a standardized and digital system, all of that is offloaded to these devices, which makes that much easier. The other advantage is that the DALI system in particular uses a very slow data rate with a very high current. So in a lot of installations, that current is certainly a minimum of 50 milliamps up to, I suppose, a more typical 230, 250 milliamps, which is almost an order of magnitude higher than the majority of your digital systems. So that means, unlike, say, something like DMX or a lot of the faster moving technologies, they are a lot less susceptible to noise. It allows you to have a lot greater types of topology, and means that you can actually run it in the same cable as a mains line. So in your DALI networks, you can actually have a 5-core cable, active neutral earth, and your DALI within that same cable, and without the worry of actually having that sort of noise or induced voltages on that device. Okay, we talked about how we can address. We have 3 levels of addressing depending on how you're looking to control those lights. So the standard actually allows individual lights to be communicated, but if you've got a group of lights that you're interested in, most typically a particular room or a section of a room, then you can assign them to a group and you can send commands just to that group. So that greatly speeds up the rate at which you can control your lights. So again, in some other technologies, they would subsequently actually send this address or this dim command to every single address. And that would mean that some would receive that address before the others. And on very fast moving systems, you might actually see some of those lights turn on or turn off before the other lights in that same room. But when you're using a group, every single light hears that command at the same time. And even though it's very slow, it's able to then start that dim, start that process of moving from the first level to the next level at the same speed. All right, so we're here today to talk about DALI in smart lighting. To summarize the major advantages, we are looking at cross-manufacturer compatibility, meaning that you can use system components from various manufacturers in the same projects, on the same lines, and in the same networks. We can reconfigure our lighting, so it's not just install it and you're stuck. It's changeable, it's updatable to meet the sort of needs and evolving spaces of your building. It gives you a high level of control as well. So scenes, group broadcast commands. And finally, it reduces the costs of your cabling as well. So instead of our individual switch circuits and our phase control dimmers, where we're running back to base cables with every single lead, well, we instead have a single circuit and the control that's sent out to each of them. All right, so who is DALI? So there is 2 main groups that are involved with actually developing and maintaining the standards. Those are the IEC, TC34WG11. So the IEC is obviously the International Electrotechnical Commission, or the equivalent in French, I believe. And this group, TC34WG11, maintains both the 62386 standards and the only other standard for lighting control, or IEC standard for lighting control, which is the 0 to 10 volt conversion. So there's a fun fact for everybody. Inside the IEC, this is actually made up of country representation. So each sort of what they call a national committee, and there's one for each country, will elect a working group member or an expert, as they call them, and nominate them to represent the interests of the industry in that country at this group. For Australia, fortunately enough, that's actually my position, and I was on a Zoom call till almost midnight last night because despite being a global organization, they do love their European timings. The advantage of an IEC standard, though, is that it can be used by anybody. So that means there's no royalties, no commissioning to be paid. Anybody can download that standard from the IEC and implement a device against it. So it's very beneficial to people that are trying to actually move into this space. It greatly reduces the barrier for entry for companies and new entries to actually start making these parts. So there's no sort of like old guard or old boys club or sort of licensing. Everybody has the right to download that standard and to use it. Now, the other group that is involved with it is the DALI Alliance. Now, the DALI Alliance has had a few names. It used to be DALI AG, which is actually a German ZVEI group. It was then the DIIA, or the Digital Illumination Interface Alliance, and they very recently changed their name to the DALI Alliance, although they still trade under the DIIA name as well. So this is the group that actually owns the DALI trademark. And it's important to know that just by implementing a device to the IEC standard, that doesn't give you the right to actually use the trademark. So this is a branding, and what it represents is that you have taken a device that is compliant to the 62386 standard, and then you have had that device certified against the test sequences developed by this DALI Alliance. Okay, so it's a little bit of a symbiotic relationship between the two. The IEC continues to develop and update these standards, and the technical and certification, TNCWG, working group within the DALI Alliance is then responsible of making the test sequence. The other very important role that they play is to address the ambiguities in a particular standard, right? So the issue with the IEC, they are very good at publishing and generating these standards, but the update lifetime, the cycle is quite slow. And once they've published it, it may be the unfortunate scenario that only, I don't know, a couple of months later, people notice that within that particular standard that there could be a clause or an instruction that could be interpreted a few different ways. And there's some ambiguity, right? But to update it in the IEC, it takes us at a minimum sort of 2 years to make that update. So in order to have interoperable systems before then, the DALI Alliance actually maintains a list of clarifications. And as part of developing this test sequence, they will actually make a decision on what that ambiguity is. Now, that doesn't mean that everybody is going to be happy with that decision, because very often different manufacturers may have implemented that particular scenario differently. But it still generates an immense value because we are better to have a less than perfect solution that is the same for everybody than a collection of perfect devices and a whole heap of devices that weren't done very well at all. So that is an important role that they play. And with those clarifications, with those updates, they will actually feed that information back. So quite a big part of the meeting that I had last night was actually bringing forth all of the sort of little bits and pieces that people have found in the standard for the last couple of years that we've already made a decision, formalizing that and actually issuing that an amendment in the IEC space so everybody's able to actually go out and start implementing against that again. The DALI Alliance is an industry alliance. You do have to sign up. Though at the moment we have 298, I actually found out there was one more in my meeting last night, member companies, and that represents the vast majority of the lighting control and the LED driver industry. So it's quite a wide-reaching space as well. All right, so DALI version 1 has been around for a number of years now, although the test and certification has really only sort of come to the forefront over, I guess, the last sort of 5 years. So even with a DALI 1 device, choosing a device that is certified, that has the DALI logo, means that you expect 100% compatibility and that has been tested and approved to work. So you can find devices, if you're looking at buildings, you can see them at your dalialliance.org/products. Fun fact, you can also type dali2-org/products and it will also come up. They did register that URL. So if you're looking at a specification, looking to choose devices for your particular building, then that is really a great first place to start to get a list of those devices that are certified that you do have confidence will work in your particular building. All right, what's the scenario in Australia? Well, we're also been very fortunate that towards the end of last year, we actually adopted the entire suite of IEC standards as a AS/NZS standard. So the fact that they're adopted now means that it actually went through all of the relevant committees in Australia, and it had consensus from all of the stakeholders within the industry that gave it that endorsement to say that, look, this is a standard that we think has value to the lighting control industry in Australia. Some of the advantages to that means that these standards are now far more accessible. The purchase price of buying this off Standards Australia is considerably less than the purchase price of buying it off the IEC. It also means that it will be available in places like state libraries and universities and other places that have access to these Australian standards. So it means that for the local industry, it gives them that ability to actually move towards a standardized way of controlling lighting in buildings and makes the information on that standard more available. It also provides some guidance then in procurement and particularly in government procurement towards the type of technologies that should be used in a building to ensure that each of those systems in your lighting control space is going to work together. With the adoption of the standard, it actually is a little bit of an Australian first. It means that it's our first Australian standard for input devices such as sensors and switches. It's also the first Australian standard there for emergency test and monitoring, because whilst 2293 describes how an emergency device should work, it does very little to actually describe that test and monitoring system. And this 62386 Part 202 steps in to fill that role. All right, DALI 1 has been a great standard for a long time, but we have moved to DALI 2 originally in 2014. So this is actually 7 years old now, but it took a few years to really get off the ground. I would say it's probably been prevalent in the industry for about the last 4 to 5 years of that space. Now, the DALI 2 update did quite a lot, predominantly for output devices. It was about fixing inconsistencies, fixing some of those ambiguities, but it did do a few small things that were different. So we've actually got much longer fade times now on those devices. We have a few more configuration commands, but for an output device, the biggest advantage that it brought was actually a new set of test and certification. So it actually brought with it the ability to certify and accurately test a lot more of these drivers. That, however, is not what most people are going to be talking about when they're talking about DALI 2. The biggest advantage is that it brought in our input devices. So in the DALI 1 space, output devices were standardized. So things like an LED driver, a fluorescent, incandescent drivers, relays, emergency devices, 0 to 10 volt converters, each of them had subparts that described how those particular devices should work in your system. But input devices, things like PIR sensors, lux sensors, switches, key switches, and so on, they were not standardized, and they were up to each individual manufacturer to determine how they were going to work. So the interoperability between those devices was slim to non-existent. So the really exciting thing in the DALI 2 is that now we can actually standardize. We can take an occupancy sensor from manufacturer A and an occupancy sensor from manufacturer B, use them together on the same system with the same application controller. So that's great. And we're going to talk a little bit about how it does that as well. And really the big thing is that we have simplified input devices, okay? So in a traditional, what I'm going to call multi-master DALI 1, or let's even say a DALI 1.5 system, the actual input devices had to be a complicated control system in their own right to be able to provide a good user experience. And let's have a little bit of a look at a network there. Okay, well, we're looking first at all at a DALI 1 with some separate network. And this is fairly standard for a lot of the systems because there wasn't any sort of standardized way of putting in these sensors and these switches. So what we tend to find is that we had some other communications protocol, okay? And this meant that out to every switch, every sensor, there was actually a separate network to the lights, to the emergency lighting, to the other relays in that building. And within that network, most of the time this was proprietary. And even within some of like the big building management systems, the actual usage of these devices was specific to a manufacturer or a few manufacturers. So that meant things like sending any notification of occupancy or push buttons was down to how a single protocol had implemented it and any configuration. What that meant though is that as you use that building, if you needed to replace a part, you would have to use exactly the same part, or at least a part from the same family to put that back in that network. We then moved to the idea of multi-master. This gave a lot of advantages because now we had the same network. As you moved into one particular room, you could have your switches, your sensors, your lights, your emergency, all on that network, and drastically cut down the amount of wiring you had and drastically cut down the amount of sort of time you had to spend commissioning those systems. But we still had the issue that the actual sensors had to be very complicated devices. And I'll give you an example of that now. So you can imagine in one of these systems, these sensors themselves were typically the ones that are actually sending the lighting command. So if someone walked into that room, this sensor is going to detect it and it would say something like lights in group 4 turn on. Okay, now that's great. If nobody moved in that particular room, well, the sensor would have some sort of timeout, and after about 15 minutes, we're then going to get lights in group 4 dim down to a warning level. A few minutes later, lights in dim room 4 turn off. Now that's fine when you have one sensor. What happens when you then start putting a couple of sensors in that room? You might have had one at each opposing corner and you've got people moving around that room. So even though that first sensor has only detected someone when they've first entered the room, someone is still in the other corner and the other sensor is still detecting the motion and the presence of people. If there was no communication between those two devices, you would find that even though someone was in the room, that first sensor near the door is going to turn those lights off after 15 minutes. And that's a bad experience. So what actually had to happen is that we then had these proprietary commands, often things like DALI or other sort of little modifications on the base protocol, and they were sending these little sort of pings between them. And the first sensor would say, okay, I've still detected someone here, and let that other sensor know that there's still someone in that room. So don't turn the lights off just yet. Look, I'm still seeing someone. And these two devices had to start talking to each other to ensure that the lights were only turned off when that room was vacated. When we started adding switches, it then could make it more confusing again. So say we wanted a button on the wall that disabled the sensors. So we're going to play a movie in this room, or we're going to start a video conference call. People are going to be moving very still, and we want the lights just to stay on for 2 hours. Or you're watching a movie, you want them to stay off for 2 hours, right? When you push that button, again, it's going to have to send some sort of proprietary message up to these particular devices and let them know, hey, shush up for a while. And so look, that worked, but the interoperability was very poor. If you had a device from manufacturer A and you put a device from manufacturer B on that same line, then they weren't going to be able to get these communications between the devices. And it meant that you were again stuck with picking a single brand of sensor for your entire DALI line, even if a different manufacturer or a different option would have been better in that particular scenario. Okay, so that brings us to what we have done in DALI 2. Now, the big thing is that we've actually made these devices much simpler. So instead of having an input device sending a lighting command back out to our devices directly, these things now just send what we call an event message. So an event message is a very simple string of commands which introduces who the sensor is and what fun information it has to tell the world. So if we go back to that same example where someone's walking into a room, that sensor is then going to generate this event message, and it will say, hi, I am sensor at address 4. I have detected occupancy, okay? If the other sensor in the room sees someone a few minutes later, it's going to say, hi, I am sensor at address 5. I have detected occupancy. Nobody moves. Those sensors will eventually say, I am no longer detecting occupancy. And they've got a couple of key states, which we won't get into too far, but it has initial occupancy, still occupied, unoccupied, and still unoccupied. So you can sort of imagine how these will announce the change in status and then sort of update the information on that line with that status as well. And what information it sends is configurable via the DALI standard. So actually giving these things an address, telling this device what information you're interested in, that's all part of the standard. But what it doesn't do is talk to any lights. It's not going and saying, hey, light 4, turn on. All of that information is then run by your application controller. So we've sort of moved all of that intelligence back to the application controller on the line. A lot of the time, this is going to be a DIN rail. That's a very standard way of installing an application controller, but it's not exclusive. You could have an application controller built into a light, a switch, or a sensor, or you could actually have an application controller and a little module that just sits behind your wall box as well. But for the purpose of what we're doing here, a DALI 2 system needs to have an application controller somewhere, and it will listen to those event messages. So we'll move over to the role of the application controller. What is it going to do in this scenario? Well, it's just heard from sensors 4 and 5 that it's got occupancy. It's then going to listen for that occupancy, look up in some sort of internal logic, and it will say, okay, well, I know that those sensors are in group 4. I'm going to turn group 4 on, and I'm going to start a timer where after 15 minutes, I'll turn them off. And if I don't hear from address 5 or address 4 again, I'll know I can turn the lights on. But if I hear of a motion event from either of those two devices, I'll reset that timer and keep going. So our switch, very similar. So again, the switch, if you tap it, it's going to send out an event message and say, hi, I am address 2. I've been pushed. And the control system is probably going to do something like, okay, well, the lights at the moment are off. I will turn them on. If you push and hold that switch, it will send out an event that says, I've been pressed and held. And then every sort of half second or so, it will send out another event saying, I'm still being pushed. I've still been pushed. So that controller knows that it can then start sending a dim up command and then continue to send dim up commands afterwards. So again, the great thing is that how these devices actually work, even though they're very simple, they are the same. And across any manufacturer, if you grab this particular sensor, install it on the line, then you're going to expect to see that event message in the same format. If that sensor had lux control, for example, then you're going to see those messages in the same format. And you're going to know that when the light has changed by a certain amount, it's going to send that information back. So that means that your configuration is standardized. It means that you can use different devices across your network. And that does greatly simplify what we are trying to do there. Okay. The other advantage is, of course, that we then have simplified cabling out to our building. Because we're moving all of these roles, all of these tasks onto the single lighting control network, we can start to actually consolidate some of the systems. So if we looked at what buildings may have looked like in the not so distant future, then you would very typically have some sort of Ethernet or BMS backbone. Then you might have a dedicated line for your emergency devices. You might have a dedicated BMS system for your switches and sensors, and then yet another gateway out to your lights on that particular line. So we could be having 4 separate sets of cable actually running around that building that you've got to install, you've got to manage, and you've got to commission. You've actually got to pay commissioning engineers to go out and commission each of those independent lines. And the actual sort of communications between the two of them, I like to consider it like a Venn diagram. You've got everything that system A supports over here, everything that system B supports over here. And what you can achieve from your total system is only that overlap between the two of them, okay? So if it's supported in the DALI space, but it's not supported in the BMS space, even if you've installed new devices, updated your controllers to support the latest protocols, well, you're not actually going to be able to do anything with that information until the other system supports it as well. Whereas if you have one system that's looking after the input devices, emergencies, lights, as these updates have become available, it is very simple to actually increase the capabilities of our system. The DALI 2, of course, well, just the two. We've got our backbone as we're moving across, and all of our devices converged onto that single line in the system. Okay, the other thing that we talked about was improved testing. So one of the big problems with DALI version 1 testing is that we were relying on this declaration by a manufacturer, okay? So the rules were, in all honesty, fairly lax. The actual standard to be able to put the symbol on your device was to essentially email in a form or submit the form online and say, yep, I declare that my device has passed this standard. And for the most part, that was fairly good. People typically did the right thing, but it was very easy to make mistakes. If you weren't running through a standardized test sequence, if you weren't having someone validate how you were doing that test sequence, it was easy to make some mistakes or to overlook something that could be critical in an actual installation. In the DALI 2 space, it actually requires manufacturers to utilize a third-party test equipment. Most commonly is our friend, the Probit Lab here, a nice 30,000 euro piece of equipment out of a nice company in Germany. And when you've used that piece of equipment, it then actually generates these test and certification files, and those files are sent to the DIIA where they are assessed. So there's actually somebody checking that each of the tests have been run correctly and that each of the results are valid, and that has to be approved before your device gets listed. And that happens for every variant of your device as well. So certainly the scrutiny on devices that are listed as a DALI 2 product on the DIIA website is much higher. Now, a lot of people might say, well, look, if we only use DALI 2 drivers, that's going to reduce the scope of how many devices there actually is going to be to use. But the fact is that that's just simply not true. As of the middle of last year, there is now more currently registered DALI 2 drivers on the DIIA than there ever was DALI 1 products. So the actual pool of possible products that you can choose to use in a DALI network is bigger than the DALI 1 network ever was, okay? All right, some of the other advantages of using a DALI 2-based system is that we are typically moving this actual control, this configuration, back to a device that is network connected or sitting at a central point. So that application controller that we talked about before, that's looking after all of the configuration, all of the commands. It looks after how the sensors operate, the sequences that go. And that means that the actual integration is easy because we just have to talk to that one device. Where you had the system of every sensor and every switch making their own decisions, then integration had to be often on the DALI line, and it was often limited to just more or less simple DALI commands because it was very tough to actually individually target each of those controllers. On a new system, we are doing that again, just back to this point. So we've got the application controller that gives you a really easy position to connect things like your AV, BMS, HVAC, MQTT, look, the options are endless, and because we're interested in DALI 2, not the rest of it, we won't spend too much time there. But yeah, that's what it means, is that as you scale up your building, you just have your single points that are looking after each of those devices. Okay. All right, emergency testing. In Australia, we have 62386 as the only cross-manufacturer compatible emergency test and monitoring system. So that means that where you want to be able to pick and choose between manufacturers, where you want to be able to replace the devices, then by using the DALI 202 standard, you can actually achieve this. You can pick the parts that are actually the best for that network. Additionally, this 62386-202 system has been designed with country-specific standards like AS2293 in mind. In fact, that was one of the big reasons I originally joined the IEC TS234, was to make sure that as we were rolling out the updates and the certification programs for these DALI devices, that they did consider the particular requirements of 2293 in Australia. So very much you can use your 62386 or DALI system as part of our compliant 2293 system. You can't say that the DALI system is 2293 compliant because it doesn't actually cover that in that 2293 standard, but it certainly can be used and can fulfill some of the obligations for your test and monitoring of those devices. A lot of systems, and again, that's going to come back down to a manufacturer-specific question, they will also bring on board things like your electronic logbooks, your electronic reporting of device locations, which are all requirements that would have been in that 2293 and now can be achieved in electronic or digital form instead. Okay, the other advantages with using a DALI 2-based system is that a lot of your modern DALI 2 application controllers can support both normal and emergency lighting on the same system and often on the same network. So for the facilities management teams out there, for the people that are actually looking after these buildings, it gives them a little bit of a one-stop shop to be able to come and manage all of the areas of their lighting control. Okay, emergency lighting upgraded. So very recently, particularly if you've been following the DIIA on LinkedIn, you will see that they have actually announced an update to the DALI test sequences. Now, what they have done here is the DALI Part 202, so 62386 Part 202, which is the emergency test and monitoring, that is still edition 1. So that was written with the first edition of the base standard in mind. Over the last few years, we have been updating the base standard. We've moved things like LED drivers and fluoros and relays to this DALI 2, but we still had a little bit of a misalignment on the emergency side. So one of the projects that's just been finished is that they've actually now updated the test sequences and updated a set of recommendations so that you can use the existing specification for your emergency with the base standard for the DALI 2. So that means that you get compliance on things like the system timing and the startup times and the interoperability with the rest of the devices. It's important to mention this because there is a little bit of confusion in the market that this isn't edition 2 of 62386 Part 202. I got an update in our meeting last night, and the actual edition 2 of this standard, which was one of the projects I authored, is due to be released as an FDIS, so the final draft of international standard, in late November this year. So we will finally actually see that come out to FDIS. It will go out for public comment and hopefully be released through next year. But that means actually emergency devices using edition 2 of 62386 6 Part 202 are unlikely to actually be certified for a couple of years through DALI. So in the interim, we are using this hybrid of the DALI 2 for the base system component and the DALI 1 for the actual emergency lighting component, which has allowed us to update and address some of the ambiguities in that original standard and make it work better across our actual buildings and schemes as well. All right, conscious of the time, one of the last things that we actually wanted to talk about today was DT-8, or in human-centric lighting. Now, human-centric lighting itself is a huge topic, right? And that's something that you could dedicate a webinar to. It is important to know that human-centric lighting is not just changing the color of the lights, okay? Human-centric lighting is about making spaces that people are comfortable to live in. And DALI can help with that in a lot of ways, such as dimming lights on and off instead of just turning them all the way on, all the way off, avoiding that sort of blackout type scenario. The DALI is also beneficial in doing things like keeping lights in a car park, for example, at a minimum level whenever anybody is any section of that building, okay? So there's a lot of areas that human-centric lighting can be implemented, and it's very important for us to consider our people in the building. However, rightly so, one of the big improvements has been this tunable white. And the DALI 2 system has made it much easier to achieve tunable white or color temperature control in a building, okay? So traditionally, when you wanted to do this, you would actually have a warm white device, you would have a cool white device. They would both have separate addresses, 2 addresses on each device, and you would have to have your control system actually calculate the levels of each one to be able to get your desired lighting. So that meant that the control was complicated and the commissioning was quite complicated as well, because a lot of the time you would actually have to go to site and measure the color temperature with a sort of color temperature sensing measurement, not a standard lux sensor, and actually calibrate these devices and the movements over the day. The other thing that was tough was actually dimming them, because inherently, as you dim to different levels, you're going to get an offset on the color, right? So one of the big problems was that whilst you could generate this sequence that moved from a warmer to a cooler color over a range of intensities, you would actually have the issue that if you wanted to put a button to temporarily dim the lights up and down or adjust the color temperature, that was hard. And we'll look at one of those examples here. If you say had the lights at 30% and 20%, which gave you a color of 5,000 K, an intensity of 50%, because obviously we're mixing these 2 colors. I have assumed 6,000 and 3,000 my calculations here. Then we press the dim down button a bunch of times to dim down 10%. Well, after that 10% dim, we've seen not only have we overshot our intensity because we've dropped both of them by 10%, but we've also got a color shift, okay? So it's not the same color before and after. And if you dim all the way down until such point that you reach the bottom or the top, one of the devices is going to hit their minimum level, and you'll actually end up that the color will move back to the same, and it's just going to be 50% between the 2 of them. It's pretty hard, right? On a DALI 2 system, the individual device calculates that for you. So you send dim down 10%, and it actually works out that in this case, it would go to 27 and 18%, which would mean that the color drops, I've made a typo there, the color drops to the same and the intensity moves down by that 10%, okay? And the advantage is that's done by the device. It's really as simple as saying, address 5, go to 50%, go to 5,000 K, and it will work it out. And regardless if the 2 LED colors are, say, 6,000 and 3,000 or 4,000 and 2,000, if it's within the range that it can achieve, each of those devices will work it out by themselves, go to that level by themselves, and across your devices and across the manufacturers of those devices, it will be the same, because it's actually worked out by that device. Previously, if you actually had two different types of strip in your light, one unit was 5 and 2 and one unit was 6 and 3, you'd actually have to send different combinations of commands to both of those devices to be able to achieve that type of mixing. The other one that I haven't mentioned here is that it used twice the number of addresses. As we all know, the DALI network supports 64 devices on each line. And if you're using color temperature control, you lost half of them straight away because every light used 2 addresses, which meant a maximum of 32 devices. With DT-8, you can use the entire address space. So back up to double the number of devices and half the cost of control systems per luminaire. So yeah, of all of the things that we've done in DALI 2, this has made one of the biggest single differences in an industry. It is much, much easier now to have good quality and easy to commission tunable white lighting. In fact, it isn't that much harder than addressing a regular device. You give it one address for each of the devices, and setting up a basic color change pattern over your day is typically trivial. You don't expect to see much more expense at all over a white light only system. All right, open standards. Why have we been talking about open standards? What is the big advantage? Well, really, the big thing is risk. Okay, that's what we've sort of been talking about the whole time here, is that we've got risk both in the construction of our buildings and the lifetime. By choosing a standard that you are able to actually choose parts from different manufacturers, you reduce your supply risk. If you need a specialty sensor that has, I don't know, ultrasonic or 30-meter detection radius, if you're on a proprietary system, you have the selection of the devices they make, and if they don't have one, well, you're out of luck, okay? Whereas in DALI 2, you can actually go out to the market and you can choose. There are manufacturers that specialize just in making those specialty devices. You can bring them into that system. You minimize the risk in your sourcing. The other one is actually component availability. At the moment, I'm sure anybody that's involved in the construction is going to know how hard it can be to get stock. When you're based on an open standard, you actually have the possibility of substituting in another part. Okay, obviously you're gonna have to get it approved, make sure that the architect is happy with how it looks, but the fact of the matter means that your project has a much better chance of moving forward, because if manufacturer A doesn't have enough parts, you can use some from manufacturer B. So that's always a great part about using open standards. But it's not just in the construction, it's also the through life. I'm going to pick a little bit on something like the Bluetooth mesh proprietary standards here, but there is buildings now that have been out for 2 or 3 years where the original Bluetooth implementations, the companies that have made that have moved on. Their current systems are no longer using the same technology as the original ones. So you just can't buy replacement parts for that system. The same thing happens if you choose a proprietary standard for your input devices in a modern building. You have to hope that in 5 years' time, that particular manufacturer is still going to be around and available to supply that part. And if they are around, well, you're basically at the mercy of the costs that they want to pay. And if they're not around, you're looking at actually ripping out an entire line of lighting control to put in something different. Whereas when you're using a DALI standardized part, well, you can go to whomever is making that part at that time, pick the component, use it in your system. And DALI has a strong focus on backwards compatibility, right? As we're developing these standards, we're always looking at making sure we can support old sites. And I guess the proof's in the pudding there that modern drivers are routinely used on sites that are like 5 to 10 years old, that you can go take a modern driver now, and for the most part, you can install it on an old site and get that system up and running again. You don't have to start replacing components. And that's the direction that we think it's really important to move through in buildings, because we want to support our buildings for 10, 20 years. We want to be able to update and make sure that they still fulfill the role that they need to fulfill, right? We're moving into an era where the circular economy is going to be more and more important, and we're going to have to actually start making sure that as we design buildings, we are designing the serviceability, making sure that we can actually maintain, repair, and upkeep instead of actually having to rip out and replace every time there is a change to be made. All right, thank you very much everybody for listening. There's probably a few topics you are going to be asking about that we will cover in the future. So the D4I is going to be another topic for our webinar, where we're looking specifically at drivers built for interluminaire, i.e. small networks just within a single device. The DALI Plus, which has very recently been released on DALI Wireless, and DALI networks for data, and looking at the ways that people are actually starting to use DALI networks to carry not only lighting commands, but information like environmental sensing, building control, beacons, so on and so forth. All right, that is myself done. I think we will move over to Dale there, and we can actually go through a little bit of the Q&A.
Yeah, so before I get into that, if there's anyone sitting there with any questions they've got that they've, send them through. We've got a few ready to go. I'd like to introduce Anthony now, actually, to help us out on this panel if anyone has any questions. So Anthony is an electrical contractor with over 15 years experience and nearly a decade as a product and technical manager in the lighting industry. Currently, he's Tridonic specification manager. Anthony represents Australia as a technical expert on IEC committees. Oh, here we go. TC34 SC34C, TC34 SC34D, TC34 WG14, TC34 AG4, and TC34 Plenary Committee. These groups are responsible for the development and maintenance of all lighting related standards, including everything from control gear components to lamps and luminaires. Domestically, Anthony represents Lighting Council Australia on EL041 and EL04111, responsible for the review and adoption of IEC standards and relevant modifications to such standards for use in the Australian market. Anthony's primary role with Tridonic is the development of product specifications, technical support and solutions, provision for Tridonic's customers in what spare time remains. He enjoys spending time with his family, woodworking, reading, and language learning.
Thank you, Dale. You got through that all right?
Yeah, it's all the technical committee ones that kills me. So we've got a few questions that have come through here. This is an interesting one, especially if something is DALI's new to you, rather. We've got, when you dim to 0 / turn off the fitting, does still have live voltage running through it?
I guess,
Anthony, as our resident electrical expert.
At the driver, yes, the drivers remain powered even when the output is switched off. So if you're talking about maintenance, you have to be aware of that before you start pulling wires out.
Yeah.
I think it's worth mentioning there that the modern DALI LED driver from our leading manufacturers are starting to actually approach standby power of less than 0.1 watts as well. So the actual risk of, say, energy consumption from having these devices powered now is actually very low, and it far outweighs the, I suppose, little bit of standby power by the savings that you can have in the day, even by, if you can turn it off for 5 minutes longer than you would have otherwise in the day, even less, you've already offset that standby power. So whilst, yes, it does use a little bit of power, the actual advantages of having a control system give you orders of magnitude more energy savings over the day as well.
Thanks, Alan. And sorry, Dale, I'll just add one more point on that. One of the problems we've always had with switching LEDs is inrush current. And the advantage of the driver remaining powered is that the capacitors remain charged, and inrush current is pretty much eliminated after the original power cycle.
Yeah, I have seen problems with the inrush currents and especially modern RCDs, having trouble with that and handling that if they're all turned on at once. So yeah, that's a good point. Another question we've got here is, which sort of comes down to a bit of logic and stuff, is what happens in a DALI group if a driver fails and is replaced? Does it automatically find its address and slot itself back in, or does it have to be specifically addressed and integrated, or can the new luminaire learn from adjacent devices?
Okay, that is a good question. And in this particular scenario, the answer comes down a little bit to both how you are controlling that device and the particular control system that you're using. So if you're using a broadcast-based control, then obviously any replacement device is going to respond, even without providing it with a particular address. If you're using a group or address-based control and you've pre-addressed that fitting, then it very much is possible to issue a fitting and it will start working straight away. However, if you just put a device that's unaddressed up there, then by default, no, it won't learn its address from adjacent devices. But a lot of that middle work can be done by an intelligent control system. So whilst it's not a feature of the light itself, modern control systems can do a lot of those type of things depending on how they're being configured. So some systems may automatically group all of the devices connected to a particular output together. Some systems may have a system where when you replace one device and place another one in, it will be able to detect that there's a device missing and then automatically reconfigure. So these are things that are still important to actually check in the control system that's controlling it. And whilst we talked a lot about the standardization of the line devices, there is still a lot of very intelligent people out there putting a lot of consideration into how you do good control. And that remains I suppose, the secret sauce or the intelligence in the system, which is sort of sitting in those application controllers. And there is quite a lot you can do just by addressing that problem intelligently.
Yeah. So one of the other questions we've got is about the AS2293 testing, and and it sort of relates a little bit actually to the third question of they're asking about whether these things can be interrogated remotely. So your emergency lighting test, can that be interrogated remotely? And one of the ones was in human-centric lighting, is there any preset algorithms? And I think or do they need to be individually set? And I think that goes a little bit back to what you were just talking about the intelligent. You can have the DALI standard, but it's what you do with it on the software side that really counts.
Yeah, okay, that is correct. So if we are looking at the remote interrogation here, then very much the point of our DALI emergency test and monitoring is that it provides us with some central place to pull the information from all of the emergencies on your line. So in that nature, yes, that allows the devices to be remotely interrogated. If we wanted to extend our definition of remotely to be off-site or in another location of your building, then again, that is going to come down to the actual capabilities of a particular system again. So a lot of systems will do this, but a lot of systems don't need to do this either. So there is some very good emergency test and monitoring controllers that can be as simple as a panel on a wall. And you just walk up to that panel, and in some buildings, that's great, right? Some buildings having the whole lot in one area or the whole lot on a remote web interface is the best solution for that particular building. But in other areas, look, it's about choosing the technology that works for you. And in the DALI space, we can use these devices from whatever manufacturer with the control system that makes sense for that building.
One for you, I think, Anthony, would be what sort of improvements are being made to emergency? So Allan briefly sort of spoke about the new standard that's being released. Is it just sort of standardizing thing, or are we expecting to see some improvements in what emergencies can report to the system?
Look, I think one of the big breakthroughs recently is the ability to have wireless communication with emergency lighting. And that's something that Allan touched on and will be a future topic with DALI Plus. But in terms of what sort of information we can gain from these, the standards are pretty clear. There's not really a lot more that we need, but there are improvements being made in terms of battery charge levels and other very specific details that you might want to acquire to see the health of your battery or the health of your LEDs. And Allan is probably much more across the actual DALI side of this.
Yeah, I can share a little bit. It hasn't quite been released to public yet, so nobody go yelling this out into the wild. But the DIIA has actually been working on a new DALI subpart. They're going to call it part 254, where it then goes and extends the capabilities or the reporting. So it's not going to change the functionality of how an emergency device actually reports its information as per our test and monitoring standards, but it'll give you that little bit more diagnostic information. So it might tell you things like the number of hours battery has been discharging, how many cycles, predictions of life. And so that's still being actually worked out at the moment. I guess this is a really good time to actually plug some of the organisations that are working in this. If these are the sort of things that you find would be interested, it's well worth reaching out to your industry organisations that are involved in this space. So obviously both myself and Anthony are involved in organisations that are working and developing these standards, but also bodies like the Australian Industry Group and the Lighting Council of Australia. They will take this type of feedback and actually pass it through to the bodies that are working on this information. So if you come up with a great idea and say, hey, look, what I really want to know is what the LED aging is of my emergency device, then definitely reach out with that type of information, because these standard committees exist to try and solve problems for the industry. So it is really beneficial to actually get that sort of input there as well.
Thanks, Allan.
Good one here is how backwards compatible are DALI 2 devices? And vice versa, DALI 1 and DALI 2, DALI 2 and DALI 1.
Oh, that's that's a bit of a minefield. Drivers, for the most part, backwards compatible. Not much has changed on the driver side of things. So if you have an existing DALI network, you'll have no problem as long as the driver that you're installing is certified DALI 2. It should function just fine. It's the input devices where things are drastically different. As Allan explained before, in DALI 1, there was no standard for input devices. The intelligence was in the device, and there's not a lot of cross-brand compatibility there. Whereas DALI 2 incorporates an application controller. It's a different topology, and there are some differences there that you can't just rip out a DALI 1 sensor and put a DALI 2 sensor in, for instance. But that's.
But if we were doing maintenance on a building, I think that's, all we could get was a DALI 1 driver, a DALI 2 driver. It would still work for the most part, because the DALI driver compatibility hasn't changed.
With the exception of a few things.
That comes, So one of the things that the organisations try very hard to do is to maintain this backwards compatibility. So particularly in the output devices, the expectation is that any DALI 2 output device, so an LED driver, will work on a DALI 1 control system. The DALI 2 version of the emergency device will work on a DALI 1 test and monitoring system. Okay. The other way round comes down a little bit to the controller. Most manufacturers of a DALI 2 control system will try very hard to support the DALI 1 versions of the output devices, i.e. LED drivers. And I would say the vast majority of DALI 2 systems will still support DALI 1 LED drivers. Your limitation is going to start coming in when your control system is looking at some of the new features, such as power monitoring or some of the new diagnostics features. Then of course, those are just going to be missing on those old drivers, okay? But they should still be able to do the light level adjustments and make sure that you're getting your basic operation. That said, we do encourage the move towards these DALI 2 devices, because as we start to release new features, obviously they're only going to be available on those ones that support it.
Yeah. And I'll also add, Allan and I have both come across situations where certain DALI control systems or DALI gateways haven't coped so well with what we're now seeing as multi-device type drivers, which are becoming far more prevalent. These extra diagnostic energy monitoring type functions are all device types within the driver, and the driver therefore has multiple device types. And we won't mention any names, but there are a few controllers out there that have had trouble trying to figure out what to do with those drivers. So
yeah, I've run into that one before as well. Everything just comes up as device 255 and doesn't know what to do with it.
And that's the problem that Allan was really sort of pushing before, was this proprietary concept. Most of the ones we're seeing with this problem are proprietary systems using gateways, and they've picked a subset of the DALI standards to operate with, but they're not compliant, or they haven't taken the whole standard. They've just cherry-picked what they want to use, and now we're sort of progressing on and using more of the standard, and they're not able to function with those new parts.
Okay. All right.
I've got one more. Just why has Australia adopted DALI 2 as an Australian standard, and what do you think that means for designers and builders, making it an Australian standard as opposed to just leaving it as an IEC standard?
Okay, so we did talk about that a little bit previously. So typically, as we start to see a common usage of IEC standard in a country, and in particular in Australia, it is usually the prerogative of the local standards body to start adopting it. So if there is no local alternative, then people will move to the IEC. But as people are actually using it, as that's starting to be commonplace in market, they like to adopt it. It means that it actually goes through industry consensus. So it actually goes out to these, what we call like constitutional committees, which are made up by representatives from different industries in that segment or in that sector. And so it gives the opportunity for them to actually review that and endorse this as a standard that's sort of applicable to those areas. So it means that it's sort of lending a level of credibility to the standard, and it's lending a level of recommendation to the standard as well. So it helps the building designers pick which standard that they might use by looking at, what ones have been endorsed by the greater sort of fraternity or industry in that area as well.
All right, well, that one's it then, I think.
Oh, good. We did see a couple of, just reading through the notes. If you were looking for a copy of the presentation slides, then just email back the organizer, and we can make sure that we'll get a copy of them out to you. From my behalf, thank you very much for joining, and thanks for listening.
Yep, thank you.
Thanks, Allan.
No worries.